I want to sneak in one more lecture this week. I'll keep it short so that I can review what we've done so far and make sure you are very clear and up to date on the current situation. Talking about carbon dioxide and temperature, accounting for emissions, and then again looking at the models. Our basic science is very clear. CO2 is rising, and the rise is the most we've seen in 2 million years. This is good science. There's really no question that the numbers we're looking at right now, rising 415 and rising, is higher than we've seen because we know this through very clear records in the ice cores. We also know that rock weathering takes a long time, and so the CO2 is in the air for a long time. Once again, here is that graph between around 180 and 280. The current level listed here on this graph is out of date. We are now well past that. We know that CO2 makes temperatures rise. We've known this since Eunice Foote back in the 19th century. This is basic physics. But the way that it works within the system of Earth also helps to explain our cycles of glaciers. Nothing else does. We can look at other possible warming sources as we create these models. We can map them out. We have an idea of how much they might add or take away from warming and cooling here in the atmosphere. And then we can determine what the total warming would be and whether this fits our models. There's no question that temperatures are going up. We certainly know this for the temperature record of the last 170 years, but we're probably looking at the highest temperatures in the past 1500 years. And this is the famous hockey stick graph of Michael Mann et al. Once again, Ali points us to the fact that if the medieval warm period was anomalous, that only means that climate sensitivity is higher. And so the rising CO2, which we certainly have now, could have a much larger effect than we fear. The projections then are for unprecedented warming. And here are different projections based on different scenarios of how much carbon we're going to burn. That green line that we'd like to see in order to stay below 2 degrees centigrade above pre-industrial levels requires almost immediate shutting down of burning of fossil fuels. Is it possible that the CO2 is not coming from fossil fuels, but from somewhere else? Well, we can do some basic accounting here. Not only do we know how much is coming from these different sources, but we know there are different isotopes depending on what the origin of the CO2 is. It cannot be coming from the oceans because warming oceans should be producing CO2, should be outgassing CO2. In fact, CO2 is going up despite those warming oceans. So once again, we would expect that if the ocean is warming, then the carbon dioxide would start to outgas from that ocean water. In fact, that the ocean would have less CO2 in a warming world. But in fact, we see the ocean acidifying. We'll be talking about this more next week. Therefore, that suggests that carbon dioxide is going into the ocean despite the warming. So that for us is a sure indication that the CO2 does not have its origin in the oceans. Now, the other part of this configuration is that world energy usage is still rising. And this is despite the fact that oil and natural gas are harder to get. So we have things like the Alberta tar sands. This is the Keystone XL pipeline that President Obama shut down, then President Trump put back on the table, and now President Biden has shut down again. What we have here, what you're looking at, are sand formations that are full of tar. And you can boil these and produce a very heavy form of oil, which then can be further refined. It takes an enormous amount of energy. And the result, of course, is a complete devastation of the landscape up in Alberta. We have to do this if we want more oil, because the easy oil in the United States, anyway, in North America, is pretty much gone. This is also where we get the Deepwater Horizon. It's not that people want to drill wells in water that's almost a mile deep, but the fact is that the easy to access oil is gone. And so this is one of the only ways to get more oil. Of course, it's more expensive as a result. And then, of course, hydraulic fracturing, which we've talked about briefly. This is this process of thrusting sand and other particulates into cracks in the shale. And then this allows natural gas, but also oil. In terms of oil shale, allows oil to flow up. So these are all new technologies for getting these fossil fuels because the desire for fossil fuels is still going up. Here in terms of coal, one of the easiest ways to get coal is simply to slice off the top of a mountain. This still happens here in central Pennsylvania. The coal that was running the power plants here on Penn State, part of that came from mountaintop removal. This obviously is also devastating to the landscape because the part of the mountain that you're shaving off in order to get to the coal ends up going out into these valleys and causing a lot of destruction in that process. Looking at the next 20 years then, what do we foresee? I've mentioned this before, we've got a best case and a worst case scenario. Let's assume the world does stop burning fossil fuels. Again, the warming will continue, but may be capped at 1.5 degrees Celsius. We're at about 1 right now. There still will be some sea level rise. Thwaites Glacier, as some of you have heard, may in fact already be destabilized. So that couple of feet might still be in the cooked into the system. And of course, the climate disruption we've seen in terms of hurricanes and wildfires, that's all just a result of 1 degree of warming. We do expect that sort of thing to continue. The worst case scenario is a matter where renewables increase, but only make up 20% of the total energy makeup by 2070. This is in fact the prediction by the International Energy Agency. In this case, warming could reach 4 degrees Celsius or more. Sea level rise could reach 6 feet or more, but certainly looking out into the far distant future, up to 50 feet by 2500. And then we would project massive climate disruption. So again, these are these different scenarios, different possibilities. We are at this choice point where these different scenarios break apart. Now, the impacts of that first best case scenario. We have to consider all these because this is not just a one-sided deal. This is the complicated aspect of climate ethics. It's not just about what happens in terms of saving the planet or stopping the warming. In fact, there will be impacts even in the best case scenario that we must take into account. For example, there will be significant what are called stranded assets as oil and natural gas stay in the ground. Companies have invested a lot of money to gain the rights to produce these areas, and to have those shut down is going to be economically devastating, especially if it happens very quickly. The other piece of this, again, this is the best case scenario in the red here, if in fact we are going to stay at this 1.5 degree centigrade rise. And notice here, and you've probably seen this before, that the expectation is that we would get to 0 carbon dioxide emissions within the next 30 years. Okay? That means then to stay on this path, by 2032, a mere 12 years away, we would have cut our carbon dioxide emissions in half. Okay? And just think about the fact that we are in fact still building new power plants based on fossil fuels and putting in new pipelines, but we would be cutting in half by 2032. This here had 2010, that's when this graph was made. In fact, we have continued to rise. We're not up at 40. We are about at 37 here in 2020. So within the graph, but we're at the outside edge. And the presumption is that we are going to follow this very a severe decline in order to get to that 50% by 2032. But here's the real problem. It's not just a matter of getting to zero by 2050. The assumption here, in order to stay below 1.5 degrees, is that we're going to go carbon negative in the rest of the century. That is to say, instead of producing nearly 40 gigatons carbon dioxide, we're going to be somehow sucking out nearly 10 gigatons carbon dioxide out of the atmosphere every year. We do not currently have the technology to do that. The long term, of course, we have more solar power, more wind power, perhaps a more diverse economy. Perhaps we end up with more sustainable environmental policies. So there are these possible positive long-term impacts, but there will be winners and losers, especially if this adaptation is quick. That means, it always means, that the poor get hit the hardest by this quick adaptation. The long-term changes could be beneficial for everybody, but the short-term sudden changes could be extremely difficult. The second scenario, this is business as usual. And I give you these graphs to look at to remind you that right now we are at an exponential rise in terms of energy consumption. And only a little bit of that is coming from renewables at this point. But look at this graph here. This again is the International Energy Agency expecting oil to continue to rise at least until 2040. So this is utterly incompatible with the idea that we would be cutting our fossil fuel emissions in half in 12 years from now. So this is one of the problems that we're facing. And in fact, as we look at what's really happened, again, since this graph was produced, we see that the world consumption has been above 100 millions of barrels a day of oil. Now compare that the 100 in this scenario was foreseen to happen in 2030. So we are above this graph at the moment. Now, of course, part of the short-term impact is that there's no need to adapt the economy to new energy sources. So that's a positive thing. We don't have that same disruption that would unequally hit the poor for certain. But in the long term, oil and gas will eventually run out. It may take quite some time, especially if we continue to be creative about things like developing tar sands and fracking and such. The earth will be permanently altered. There's no question about this in the long term. And we've been talking about sea level rise. A number of you have been thinking about Florida. Let me give you two examples of delta communities. Here, the one on the right in Bangladesh, and the one on the left in Egypt. And what you notice here is that a great deal of Bangladesh, and look, here's 2 meters, so that's Thwaites Glacier right there. Sorry, Thwaites is 2 feet, but 2 meters is what we would expect by the end of the century. And note how much of Bangladesh that is. And here's the 2 meter line in Egypt, right? This is, you can't really tell from this picture, so I'll give you another one. This is very productive agricultural land. And to lose that means that Egypt and Bangladesh lose these very important industries that are feeding their peoples. So the result here is not just a matter of some land being lost, it would completely devastate the economy of these countries. Again, even with the long-term impacts, there are winners and losers, and certainly people will make money and continue to make money on selling this oil, natural gas, and coal. The disruptions, though, that we foresee in terms of rising sea levels will mean more migrations, more disease, probably more wars. This is Richard Alley's suggestion, is that the human tipping points here are something to be taken quite seriously. And then, because I think in terms of ethics, I imagine the issues, what it would be like to be a person 100 years from now, looking back in the past at our generation, when we had the choice. And the choice that we made to continue burning fossil fuels, even though we knew full well what the results would be. Can you imagine how people in 100 years would feel about the decisions that we're making? Because 100 years from now, they won't have another option. They do not have the ability to stop. It wouldn't matter. The carbon dioxide stays in the atmosphere for thousands and thousands of years.
So that's a little bleak, and it's also really fast. I apologize for that, but I thought it was important to summarize everything we've learned so far from this unit in class and what the impacts and implications are of this knowledge.